Hello world and hello YouTube and hello to the students of CS 108. My name is Reggie. Professor Kraft has invited me to give a small presentation on hash tables. So let's go ahead and get right to it. Here's my short outline right here. We're going to talk about what is a hash table and then hashing and collisions, and hopefully with a visual representation that I give you, you'll be able to understand the basic concepts of a hash table. Let's go ahead and start. What exactly is a hash table? Now, a hash table, unfortunately, is not a table full of hash browns, nor is it a table with the design of a hashtag. No, a hash table is a data structure of an associative array. And what it's used for is for inserting things, and we store them in key value pairs. It's very efficient for insertion and retrieval of said data that we've inserted. Now, I talked about key value pairs, and let me explain what those are real quick. Key value pairs are simply linked data items. So if you have a data, for example, some object, there's a key and a value that's associated with it. Keys are unique, and the values that are associated with the keys don't necessarily have to be unique. It's just the keys, because when we store the data into the hash table, it's also always based on the key. So for some real world examples here, let's take your social security number. Your social security number would be your key, and then who you are would be the value. So for example, this person right here, let's just name him John Smith. I'm pretty sure he's not the only John Smith in the world. However, he does have a social security number that is only associated with this particular John Smith. Well, that should be the case. So once again, key, the social security number, and the value being the person's name. Now for this presentation, to make it a little more fun and engaging, I've decided that our keys are going to be Pokemon, and the data is going to be the data of the Pokemon. So our hash table is kind of like a Pokédex. Now if you don't know what Pokemon are, well, it's pop culture. Just know that our Pokédex is basically going to be an encyclopedia of cute little pocket monsters that have information on them. So that's basically what we're going to be doing today. So as we have here, and it's frozen. All right. Hashing and collision. So I'm going to talk about this in tandem, and then I'm going to have a visual representation on it. So what hashing is, there are many different ways to hashing. When you get to CS310, the professors are going to go over what exactly how hashing does work. Just know that there's folding, shifting, exponentiation, and etc. etc. The Java language does have its own hash code method, but you just need to know that it's just a function that produces an index. We're only going over the basics here. So to further illustrate that, this is our array right here. It's a very small array. Normally when we do hash tables, it's quite bigger, but just so that you can get the basic concept down, I made it smaller for you. So let's say we have Pikachu here, and here's our hash function right here, a nice little filter with a hashtag. And when it goes through this hash function, it should always produce the same number. It's just going to produce an index that's going to fit into my hash table. So goes through the filter, produces the number 4. So very easily, we go to our table here and we put Pikachu in index number 4. Plain and simple. Once again, Squirtle goes through the hash function, produces 0. What do? Go into our array, and we place Squirtle at index number 0. Beedrill, hash function, 2. Where do we put Beedrill? At 2. So very, very simple, as you can see. You can understand that's basically how it is. Now when these Pokemon or data go into the hash table and we say go through the hash function, it's always based on the key, being, well, their name. Again, what if we have something that happens like this? We have Lapras here who goes through the hash function and produces a 2. Now if we look at 2, Beedrill's already here. So what do we exactly do? Well, there are many different ways to resolve this issue. This is something that we call collisions. Collisions happen when you go through objects and they go through the hash function and they get hashed to the same exact index. There's probing, there's linear probing, but for the sake of the example, we're going to go through chaining. So chaining simply, what that simply does is we think of the array at each array index, it's actually a linked list. So Lapras just gets linked to wherever index to it. So it's linked to the same index that Beedrill is in. Plain and simple. Show you another example. We have Charmander, who's going to go through this hash function and is going to produce 4. So obviously it should be linked to Pikachu. And that's that. So that's how you insert into a hash table. Now, earlier I mentioned that hash tables are perfect for retrievals as well. The reason for that is, as you can see, if we needed to retrieve, so now if I had someone who wanted to know, okay, well, what is the data of Pikachu in your Pokedex? So, well, I have to go retrieve Pikachu. So Pikachu would go through the filter, through the hash function, would produce 4, and then so now I know that I have to go to 4. Well, let's backtrack for a second. Let's say that I wanted to look for Pikachu in this array full of linked lists, but I don't have the hash function. So what would I do? Well, obviously I would go to the first index, so 0. Is Pikachu in this linked list? No, it's not. Then I would go to index 1. Is Pikachu in this linked list? No, it's not. I go to linked list number 2. Is Pikachu in this linked list? So on and so forth until I do finally find Pikachu at index number 4. Now, imagine what if this array was like a million indices. That would take forever. Now, the beauty of hash tables is the fact of the hash function gives us one index and one index only. We know that we only need to look at the linked list at index number 4. We don't have to look at 0, we don't have to look at 1, we only have to look at 4, and this is where we'll find Pikachu. And that's basically it when it comes to the basic concepts of hash tables. That's all I have for today. Hopefully that was clear and concise for you. If you have any questions, you can probably drop a question in your discussion board or wherever at Piazza, wherever Professor Kraft has you guys communicating. You can email her. You can also probably email your TA. You can even email me directly. My email will be down in the YouTube description. And that's all I have for you today. So goodbye world, goodbye YouTube, and have a nice day.